Hi grade 9s, we're starting a new section today, and that is the section of equations. It's a lovely section and we're going to get into some really exciting stuff, but today's lesson is just about focusing on the grade 8 basic examples that we first started with. So let's just quickly define what an equation is. An equation is when you have an algebraic expression on the left hand side and it's equal to an algebraic expression on the right hand side. And so basically the two expressions are equal to each other in value. Now, probably this lesson is going to be the most important because it sets us up for the basic skills of solving equations. And they're really important. And the first basic skill is something which I like to call the golden rule of equations. Now, the golden rule of equations will help you to solve equations from now until matric. It's that important. So let's look at the example I've written down. I wrote down what happens if x is equal to 3. So x has the value of 3. So what I've done on the next line is I've said, well then, what is x plus 3 equal to? Now you can't tell me this is equal to 3 still, because x had a value of 3. So if I've gone and added 3 to the left-hand side of the equation, surely I must add 3 to the right-hand side of this equation to maintain the fact that it's equal. Because if x was 3, if I added 3, surely this should now equal 6. And if I have a look at my next line, what I've decided to do is now multiply this x plus 3 by 5. Now this can't still be equal to 6 because x plus 3 we decided was equal to 6. So what you do to the left hand side, you have to do exactly the same thing to the right hand side for this to maintain the fact that it should be equal. So 5 times x plus 3 would actually have to be the same as 5 times 6, which is 30. So basically this is the idea, and I'm going to draw a picture here, and you please shouldn't laugh at my picture, but an old-fashioned kind of scale where you have, it's often used as the symbol for justice. When you have one of these, this is a terrible picture, but basically when you have one of these old-fashioned scales with the baskets, and the idea is the weight must be equal on both sides. Now, how the scale works is if you take, I don't know, this is meant to be an apple, if you put an apple in the one side, this side would go down because it's got more mass in it. And so if you want to keep these things equal, you must put an identical apple in the other side. And then they will maintain their balance. And that's exactly how equations work. The golden rule of equations is what you do to one side of an equation, you have to do exactly the same thing to the other side. It's probably the most important thing I'll say in equations. What you do to one side of an equation, you do exactly the same thing to the other side. So if you add 3 to the one side, you must add 3 to the other side. If you multiply the one side by 5, you multiply the other side by 5. So as long as you stick to this rule, you can't really go wrong. So from now on, when I'm referring to this, I'm just going to say golden rule of equations. And we're all going to know that that means what you do to one side, you do exactly the same thing to the other side. And then it maintains the fact that they're equal. So let's look at a couple of examples. All of these should be something that you probably should be able to solve by yourself. You're probably just a bit rusty. So when I teach my grade 8s, I always say to them, if you look at x plus 5 equals 10, the whole point of this is to solve for x, which basically means get x by itself. So I always say to myself, what is attached to x that I need to get rid of? So what is attached to x that I need to get rid of? And I identify in the easier examples, it's very easy, but it gets more and more complicated. So I identify everything that needs to go. So what is attached to x that I need to get rid of? Now in this case, there's a plus 5. So then I say to myself, how do I get rid of adding 5? If I want to get x by itself, I've got to get rid of adding 5. And the answer to that is something that we should have learnt in grade 8, and that's something called the inverse operation. And inverse operation means the opposite of adding 5. And we all know what the opposite of adding 5 is, but we probably haven't heard that word inverse operation in a while. It basically just means the opposite operation. And the opposite operation to adding 5 would be subtracting 5. Now, I probably wouldn't do this in grade 9 because now we're probably pretty good at equations, but in grade 8 and in all my memos you'll notice that I write, so I need to minus 5 on this side so that these two disappear. But if I minus 5 on one side of an equation, I need to minus 5 on the other side. So what lands up happening is my x plus 5 minus 5 disappears, and I'm just left with x. And 10 take away 5 is 5. Now I probably could have seen that the answer was 5 by just looking at the question. What plus 5 gives me 10? Well, 5. But we're trying to build up a set of skills here to help us solve much more difficult equations later. So I know it's a little bit annoying because you can see the answer, but let's try and build up our skills. Now, at grade 9 level, I don't expect you to necessarily write out all those steps. So I'm going to show you in question B there's 3 different ways that you could possibly write this, and we're going to write down all of them. So the first way about how I encourage my grade 8s to do it is I encourage my grade 8s to go, well, what's attached to x that you need to get rid of? I need to get rid of subtracting 2. So what is the opposite of subtracting 2? As in, what's the inverse operation for subtracting 2? And I think all of us know that the opposite of subtracting 2 would be adding 2. So I'm going to add 2 to one side, but the golden rule of the equation says what you do to one side, you do to the other side. So I add 2 to both sides. So what happens here is my minus 2 plus 2 disappears, so I'm left with x, and I get 6. Now I know I'm right because I can just check. 6 minus 2 is 4. Now that's one way to write it. There are many ways to write it. So what lots of people do now that we're in grade 9 and a little bit better is we go, oh, we're adding 2 to both sides, so my 2 disappears and my subtracting 2 disappears, and I get that. And so x is equal to 6. So that's what some people do. So some people, now it doesn't look like you've obeyed the golden rule because you didn't add 2 to both sides, but you did. Because over there, where's the minus 2? Well, it's disappeared because I've added 2. So what you're doing here is you're adding 2 to both sides, but you're not explicitly showing it. But you are actually doing it. So it's implied that you added it to the left-hand side because the minus 2 has disappeared. The final way to write this down is lots of people don't show this step, and they jump straight from there to there. And there's absolutely nothing wrong with that either. So there's lots of ways to do it. I'm going to stick to the grade 8 way for a little while, just in case you're a bit rusty, but you can always skip steps if you'd like. Right, let's look at some more examples. Now this example is an interesting one, because people don't like this generally because they think that x is on the wrong side now. Because people prefer the x's to be on the left-hand side for some reason. So there's 2 ways to do this question. You can do this using what I call the pancake flip. And the pancake flip is exactly like how if you toss a pancake in the air, well, it hopefully lands back in the pan just on the other side. Now the pancake flip is the idea that if you know that a equals b, surely this is the same thing as b equals a. You can just flip it over. As long as you flip both sides, it's exactly the same thing. So what you can do is swap the x minus 2 to this side and the negative 1 to that side, simply to make it something that you're more used to. And now it's a much easier question for you. So now what I would do is I would say to myself, well, there's a minus 2 attached to x, so I need to add 2 to both sides so that that minus 2 disappears. Then I'm simply left with x, and minus 2 plus 1 is 1. And I can always check my answer so I'll know if I'm right or wrong. Now you don't have to do it like that. You don't have to pancake flip. So what you can do if you want to is say exactly the same logic, but just keep the x's on the right-hand side. So I say, well, I need to get rid of subtracting 2. So I'm going to add 2 to both sides. And so I land up on the right-hand side with just x, because my minus 2 plus 2 disappears, and on my left-hand side, minus 1 plus 2 is 1. So I'll end up getting exactly the same answer. They're just written the opposite way around, and there's nothing wrong with that. So you don't have to pancake flip. I only do it sometimes because it makes my life easier. Okay, now that we've kind of mastered this whole adding and subtracting business, let's look at something like 2x equals 4. Now I can clearly see the answers too, because 2 times 2 is 4. But we're trying to learn a skill. So I say to myself, how do I get rid of multiplying by 2? I don't like to say, how do I get rid of the 2? Because that doesn't tell me how the 2 is connected to the x. How do I get rid of multiplying by 2? Well, the opposite operation or the inverse operation of multiplying is dividing. So I'm going to divide by 2. But the golden rule of equations says what you do to one side, you do to the other side. So what actually happens here now is that these 2's cancel. So 2 divided by 2 is 1. So I get x, and on this side I get 2. So just don't forget that golden rule. So I'm just going to write with myself a little note here. Don't forget your golden rule. Once you've decided what you'd like to do, as long as you do the same thing to both sides, you'll be fine. Okay, let's look at E. Now the question is, how do I get rid of multiplying by negative 3? Now, there's nothing wrong with it being negative. Now I see that I forgot my rid there. How do I get rid of multiplying by negative 3? Now, most people here will want to start adding 3 because they see the negative sign and it freaks them out and they want to start adding. But just be careful. We're multiplying by negative 3. So don't think of that negative as a subtraction. How do you get rid of multiplying by negative 3? I'm going to need to divide by negative 3. So I'm going to divide the one side by negative 3, but the golden rule says that I need to divide the other side by negative 3 as well then. So my negative 3's land up cancelling to 1, so I get 1x, and this is negative 3. Right, so let's start mixing the two. So what happens if we get negative 3x plus 5? Well, the first thing I do is I say to myself, what do I need to get rid of? If there's more than one thing, I like to think of both of them. What do I need to get rid of? And in this particular example, I need to get rid of adding 5, and I need to get rid of multiplying by negative 3. So the question is, which one do you do first? Now this is actually really important. Technically, it doesn't matter which one you do first. However, if we do one way, we tend to always make mistakes. So what we like to do is, if we divide into terms, there are 2 terms on the left-hand side, and we prefer to get rid of everything furthest away from x first. So not in the same term as x, all the other terms, and then we'll get rid of what's closest to x. So I'm just going to write that in. Get rid of what is furthest from x first. Now, by furthest, I mean the other terms, not in the same term as x. So I'm first going to get rid of this plus 5. So if I'm writing this out the long way, I'm going to say negative 3x plus 5, and I'm going to leave myself a gap, because to get rid of plus 5, I know I need to subtract 5. But what you do to one side, you do to the other side. Now don't forget, you don't actually have to write down those steps if you don't want. You can go straight to my next line. Now how do I get rid of multiplying by negative 3? I'm going to divide by negative 3. But what you do to one side, you do to the other side. So my negative 3's now end up cancelling, and I simply get x. Now you could simplify this on your calculator, but a negative divided by negative is a positive, and 5 divided by 3 doesn't really simplify. Now we don't particularly like decimals in maths, and so we try and avoid them, and we don't particularly like mixed numbers, so we would literally leave it as 5 over 3. You can always just check on your calculator to see if that becomes any neater. Right, let's look at this question. Now this question for a grade 8 really throws them, because there are 2 terms here, and it's the wrong way around in people's head. So this is another type of question where it might help you to change the order if you want to. Now the thing with changing order, in maths you're not allowed to just swap things around because you feel like that. We learned that in factorizing with the switcheroo. You can't just swap things, but you are allowed to change order if you move an entire term. So you move the term with its sign. And I'll show you what I mean. So in this particular example, you can't suddenly write this as x minus 2 because that's not the same thing. What you can do is you can say this is negative x. So can I write my negative x first? This is technically a positive 2. So can I write my positive 2 second equals 18. So if you don't like this, which most people don't like it being written like that, swap the orders by taking the term and moving it with its sign, and then you can solve it normally. So then I would say to myself, well, I need to get rid of adding 2, and I need to get rid of the fact that there is a negative 1 there attached to x. What do I get rid of first? Everything furthest from x. So that negative 1 is in the same term as x, so I'm going to get rid of the plus 2 first. So I'm going to minus 2 on both sides. So you would get negative x equals 16. Remember, you don't actually have to show the orange. You could just go straight to the negative x equals 16 and do it in your head. Now I'm going to divide by negative 1 because technically there's an invisible negative 1 there. And so I get x is equal to negative 16. And you can always check if you're right. Now, did you have to change the order? And the answer is no. Because there's nothing wrong with you seeing the question exactly how it is and saying to yourself, well, there's 2 terms here. I need to get rid of 2 and I need to get rid of negative 1. So exactly the same logic. Which one do I get rid of first? I would get rid of that 2 first. Now this is what messes people over. This is actually invisible plus 2. So I'm going to minus 2, exactly how you did in the previous example. I'm going to subtract 2 from both sides. So now I land up with negative x equals 16 because positive 2 take away 2 disappears. And now I'm in exactly the same position. I'm going to divide by negative 1 on both sides, and I'm going to get x is equal to negative 16. So if you're comfortable with not swapping the order around, then it's absolutely fine for you not to. Right, let's look at h. This is a case of one where we might want to pancake flip. Again, you don't have to. So if I decide to go with the pancake flip, I'm going to do both options. Then you would swap the left and right around. So you would put the 8 minus 5x on this side equals 3. Now again, I could now swap the order as well if I wanted to. So I could put the minus 5x first, then the plus 8 equals 3. Now you really don't have to if you don't want to. Either way, I'm going to get rid of my adding 8 first because it's in a separate term. But I would have done that here either anyway. So I would have subtracted 8 here on both sides. But if I've swapped the order, I'm still going to subtract 8 on both sides. So you must just pick a method that makes more sense to you. So I'm going to put the minus 5x, and 3 take away x is minus 5. Now I need to get rid of, now just be careful, I'm multiplying by minus 5. So I'm going to divide by negative 5, and I land up with x is 1. Now I should get into the habit of always checking my answers. So if I just go and substitute in 1 there, you can even do it in your head, but your calculator is always helpful. So that is 8 take away 5 times 1. 5 times 1 is 5, and 8 take away 5 is 3. So this did work. Now you didn't have to do that, so I'm just going to write an or here. If you decided not to pancake flip, then, and I should maybe leave some space because I know I'm going to need to be subtracting here. So you would have 8 take away 5x. Then you would want to get rid of the 8 first. So I would subtract 8 on both sides. And I would land up with negative 5 equals negative 5x, which is exactly that same step. It just is the pancake flip version. So I'm going to divide both sides by negative 5 because that was what is attached to x. And I get, oh, I don't know why I wrote it positive, but basically it's positive 1, which is exactly the same answer. So you might decide question by question what makes more sense to you. Okay, so those are pretty much the basics of the pancake flip and adding, subtracting, multiplying. So let's get into this idea of what happens if it was attached to a division. So this question says x divided by 2. So now the question I have to ask myself is, how do I get rid of dividing by 2? And Well, it's fairly simple, because the opposite of dividing by 2 is multiplying by 2. Just don't forget the golden rule, which is what you do to one side, you do to the other side. So if I multiply this side by 2, my 2's can cancel, but then I must multiply the other side by 2. So I land up with x is equal to 8. And I know that's right, and I could have seen that, but I'm just trying to build a set of skills before we get into the more complicated ones. Okay, let's look at j. Now j is interesting because there's two things to get rid of. I need to get rid of the 2, and I'm multiplying by 2. That's that there. And I need to get rid of the fact that I am dividing by 3. Now you can see this as one number. You can see this as 2 over 3. Now I don't like dealing with fractions. So personally I see the numerator as a separate problem to the denominator. Now which one to get rid of first? The real answer is it doesn't matter. But I always think that I hate denominators so much that I always get rid of denominators first. In every question I ever do, always get rid of denominators first, because then it immediately, I can't spell denominators, I hope that's right, first. It just means that your question is not a fraction anymore, which just makes us feel a bit more comfortable. So let's have a look here. What that means is I need to get rid of dividing by 3 first. So how do I undo dividing by 3? I'm going to multiply by 3. So I'm going to multiply the left-hand side by 3, as long as I multiply the right-hand side by 3. So 3 divided by 3, that'll cancel to 1. So I get 1 times 2x, which is 2x, and this is 18. Now I need to get rid of multiplying by 2, so I'm going to do the inverse operation. I'm going to divide by 2. But what you do to one side, you do to the other side. So I land up getting x is equal to 9. And again, I could check that on my calculator. Right, let's look at k. K now has a couple of things going in it. What is attached to x? Well, there's a plus 5 attached to x. There is, I'm dividing by 2, and there seems to be this negative 1. I don't know who this negative belongs to. It doesn't really matter. You could think of it as a negative 1. First questions first, divide into terms. Which one do I get rid of first? I always get rid of things furthest away from x first. So things that are in a separate term to x. So in this question, that would mean I'm getting rid of adding 5 first. So I'm going to subtract 5 on both sides. Why? Because then those will disappear. Now it's much easier to get rid of what's furthest from x first before worrying about this fraction. So I get negative 2. Now this negative here, I'm going to put it outside because that's where it was. It doesn't really matter who you see it belonging to. I personally would find it easier to see my denominator as 2 and think to myself, how do I get rid of dividing by 2? Well, that means I am going to multiply by 2 on both sides, because then these 2's can cancel, and I'm just simply left with minus 1x equals, and this will be negative 4. So it didn't actually matter who you thought of that negative being attached to, but it's probably easier as thinking it of being attached to the numerator. And now I just need to finally divide by negative 1 on both sides, and I'll get x is 4. I probably would check on my calculator to check that I'm right, because it's always helpful when you can move on with confidence. Okay, now that's a pretty tricky question, because there's multiple things going on there. So just to recap, very important, divide into terms. Get rid of what's furthest away from x first, and then I prefer to get rid of my denominator first. Okay, let's try another one similar to that. So similar idea is that I would divide this into terms, and personally I would prefer to get rid of the adding one first. So I have my y divided by 2, add 1, so I'm going to undo adding 1 by subtracting 1 from both sides. And if I subtract 1 from both sides, let me pick a better color, these disappear, which is the whole point. So I get y divided by 2 equals 4. And so finally I can undo dividing by 2. So I'm going to multiply by 2 on both sides. So my 2's cancel, and I'm left with y, and I get equals 8. Okay, so our last one in this topic of recapping our basics is 3x divided by 4 plus 1 equals 0. So a couple of things going on here. If I divide it into terms, that plus 1 is the first thing that I think I'm going to get rid of. That's going to have to go, and I think I'm going to do that first. This dividing by 4 is going to have to disappear. I think I'm going to do that second because it's a denominator. And then finally my 3 will need to go in order to get x by itself. So furthest from x first, I'm going to subtract 1 on both sides. Don't forget that you don't actually have to write that. You can go straight to this next line of actually doing the subtraction. Now I'm going to get rid of the denominator first. I'm going to multiply by 4 on both sides. So my 4's cancel, and I get 3x, if I cancel them out in my head, equals negative 4. And then finally, I can divide by 3 on both sides to get rid of the 3. And so this seems like a very messy answer. Do not ever be afraid of a fraction answer in an equation, simply because we often have fraction answers so that we know that the question, you couldn't just guess the answer, because so often in equations you can guess the answer and not actually do any working. Okay, so that's the end of Introduction to Equations. Just a brief recap from grade 8. Basically, what the most important thing we learned is the golden rule of equations. What you do to one side, you do to the other side. Don't forget the pancake flip. So you're welcome to flip both sides of the equation if you'd like. You're welcome to change the order of the terms if you'd like, as long as you move each term with their sign. And then lastly, don't forget that you're basically just working from furthest away from x, and you slowly work down to x and get rid of everything attached to x by using the opposite operation. Okay, well done.